Good morning, people. I hope you all had a decent Monday and a good weekend. But right about now, we should all be in our seats. We should be doing our check for understanding. If you thought that I wasn't there and things would somehow change, you are tripping. We got stuff to do this week. We got a lot of stuff to do and not a lot of time. So my expectation is that everybody will be doing their work. We'll be on our best behavior. There will be no issues. No issues. No issues. All right, folks, pencils down, eyes up here, laptops shut. We're going to get started. We're going to go over this. We're going to start with Ralph. Ralph is driving from his home to his grandmother's house at an average rate of 40 miles per hour. He had driven 6 miles when his sister Maria left their house and began driving along the exact same route. At what average rate in miles per hour is Maria driving if she catches up with Ralph in 1.5 hours? So we're going to look at that on the whiteboard. Now, here's what I see when I look at this. He is going 40 miles an hour. So that's 40x. And he got a 6 mile head start, so plus 6. Now, 1.5 hours. How far had he gone when she catches up with him in 1.5 hours? So what we're going to do is we're going to take that 40 and we're going to multiply it times 1.5. So 40 times 1.5. And 40 times 1.5 is 60. Plus the 6 mile head start that he had, which is 66. So in the 1.5 hours that Maria was driving, Ralph had gone 66 miles. He had gone 40 miles per hour for 1.5 hours, plus that 6 mile head start. Now we want to know how fast Maria was driving. So we're going to say, what is 66 divided by 1.5? And 66 divided by 1.5 is 44. So Maria had gone 44 miles per hour. Next problem we're looking at. Zelda bought a blouse and sweater for a total price of $79. The price of the sweater was more than twice the price of the blouse. What was the price of the blouse? So let's go to Zelda. So we know we have two variables. We have a blouse and we have a sweater. And we know the total is $79. And total means we're going to add. So we know that the blouse plus the sweater has to equal $79. What do we know? We can only define one variable. Now, we have no idea what the blouse was. But we do know that the sweater was 4 more than twice. 4 more than twice. 2 times the blouse plus 4. And we know that the blouse is just going to be the blouse. Now together, combined, these two things have to equal 79. So I'm going to say B plus 2B plus 4 equals $79. 3B plus 4 equals $79. Subtract 4 from both sides. 3B equals $75. Divide by 3, divided by 3, B equals 25. Or the price of the blouse was $25. And then we're on to, we're going to skip this one for now. We're going to look at this one. Which graph represents the solution of y is less than 2x plus 4? So first thing we should notice right here is that less than symbol. So that is a dashed line. So that means that A is out because A is a solid line, B is still in, C is still in, and D is out. Next thing we're going to do is we're going to check 0, 0. So I'm going to plug 0, 0 in. If we get a true statement, we're looking for 0, 0 being shaded. If we get a false statement, we're looking for 0, 0 not being shaded. So is 0, look, I'm just going to plug 0 in for y, is 0 less than 2 times 0 plus 4? Is 0 less than 4? Yes, it is. That's a true statement, which means 0, 0 should be shaded. So this would be the correct graph. Now I'm going to go back a question. All right, and our last problem is, which is the graph of the system of inequalities shown below? So when I get a system of inequalities, remember, it has to work for both inequalities. So I'm going to take this and I'm going to plug it in. I'm going to make my own graph because it's easier for me to see visually. So I'm going to say y is greater than 8 minus 3x. And my other equation was y is less than or equal to 2x minus 1. So I'm going to start with this first one. I'm going to start at the 8 because that's my y-intercept. My slope is negative, so I'm going to go down 3 and over 1 throughout. And this is going to be a dashed line. And I'm going to plug in 0, 0. So is 0 greater than 8 minus 3 times 0? Is 0 greater than 8? No, it is not. So I'm going to shade the region of the graph that does not contain 0, 0. So that's going to be everything over here on this side of the graph. Okay. And I'm going to do the same thing for this one. Y is less than or equal to 2x minus 1. This one's going to be a solid line because it says less than or equal to. So I'm going to start at the negative 1. I'm going to go up 2 and over 1 throughout my graph. And I'm going to make a solid line. Don't judge me. It's not going to be perfect. Okay. And I'm going to plug in 0, 0. Is 0 less than or equal to 2 times 0 minus 1? Is 0 less than or equal to 1? No, it is not. So I'm going to shade the region of the graph that does not contain 0, 0, which is going to be everything on this side of the line. Okay. And then notice that right in here, all of this, this was the region of the graph that was shaded twice. So that would be considered the solution to the system of equations that you see on the graph. All right. And so that would be, let's look at that again. That would be graph number B, or letter B. All right. Everybody needs to take out their notes, or we need to pass out the notes. The notes should look like this. It should start here. I'll give everybody a second to pass those out. Systems by elimination. It literally means exactly what it says. We are going to eliminate a variable. Because if we can solve for one variable, we can solve for the other. So I'm going to look at this very first example problem that we have. X plus 3y equals 14 and 2x minus 3y equals negative 8. And the first thing that I notice immediately is right here, positive 3y and negative 3y. And I notice them because I know that if I added those two things together, they would equal 0. And that's really important for me right now, because I'm going to add these two equations together because I want to eliminate one of the variables. And the first variable that I want to eliminate is the y. Because when I add them together, x plus 3y equals 14 and 2x minus 3y equals negative 8. I get x plus 2x is 3x, and then I get positive 3y minus 3y, that is 0y. Now this shouldn't say 28, this should say negative 8. Okay. X plus 2x, 3x, 3y plus negative 3y, 0y, 14 plus negative 8, positive 6. Now, I don't have to include 0y. Mathematicians are lazy. We don't write 0 if we don't have to. So what I can say is that 3x equals 6. And I'm going to divide by 3 on both sides of my equation. 3 divided by 3, 6 divided by 3, x equals 2. And I'm going to substitute that 2 in for one of my equations. So I'm going to place that 2. 2 plus 3y equals 14. Where the x was, I'm going to put the 2 in its place. I'm going to subtract 2 from both sides. And I'm going to say 3y equals 12. I'm going to divide by 3. And I'm going to say y equals 4. So my solution is going to be x is 2 and y is 4. And I'm going to check it, because I'm going to look at that second equation that I had. 2x minus 3y equals negative 8. So that should mean that 2 times 2 minus 3 times 4 equals negative 8. 2 times 2 is 4. 3 times 4 is 12. 4 minus 12 does in fact equal negative 8, so I know my solution works. Let's look at problem number 2. When I look at problem number 2, I don't have two variables that are offset. I have 2x plus 2y is 4, and I have 2x plus 2y is 7. But what I do see right here is this 2y and this 2y. And that's going to make my life simple, or simpler. Linear equations are proportional relationships. That means what I do to one thing, I can do to the other. So if I take this entire equation, I can multiply it by a number. And I'm going to choose to multiply it by negative 1. Because when I multiply my equation times negative 1, that negative 1 is going to distribute here, here, and here. So we'll have 2x plus 2y equals 4, and then we'll have negative 3x minus 2y equals negative 7. And if you see, now I have two variables, positive 2y and negative 2y, that are offset from each other. I'm going to add my equations together. So 2x plus negative 3x is negative x. Positive 2y minus 2y is 0y. And 4 plus negative 7 is negative 3. So negative x equals negative 3. Divide by negative 1. We don't want to solve for negative x, we want to solve for positive x. So I'm going to divide by negative 1 on this side, and I'm going to divide by negative 1 on this side. Negative, negative, positive. X equals 3. So now we're going to substitute that 3 into our equation to solve for y. So where it says 3x plus 2y is 7, we're going to put a 3. So 3 times 3 plus 2y is 7. 9 plus 2y is 7. We're going to subtract 9 from both sides. Nine minus 9 is 0. 7 minus 9 is negative 2. We're going to divide by 2 on both sides, and we're going to get y equals negative 1. And I'm going to check this by plugging it into my other equation. So my other equation was 2x plus 2y is 4. So is 2 times 3 plus 2 times negative 1. I'm going to write that somewhere else. Is 2 times 3 plus 2 times negative 1 equal to 4. 2 times 3 is 6. 2 times negative 1 is negative 2, and that does, in fact, equal 4. So we know that our solution happens at 3 and negative 1. We're going to try one more. 3x plus 4y is 26, and x minus 2y is negative 8. Now, what I see is I do not have two variables offset from each other. But I do have a positive 2y and I have a negative 2y. Or I'm sorry, I have a positive 4y and a negative 4y. And that's important because, like I said in the previous problem, elimination and proportional relationships. These are proportional relationships. So that means I can multiply something throughout my entire equation without changing the relationship. And that's important here because I'm going to multiply everything by 2. So I'm going to take this second equation, this bottom equation, I'm going to multiply it by 2. And what that's going to do is that's going to carry throughout the entire equation. So now we're going to have 2x minus 4y equals negative 16. And you should see here positive 4y and now negative 4y, which means that we can balance these two. So 3x plus 2x is 5x. Positive 4y minus 4y is 0. And 26 minus 16 is 10. So we're going to say that 5x equals 10. We're going to divide by 5 on both sides. And we're going to get that x equals 2. So I'm going to substitute that 2 in to my equation. So where I see the x, I'm going to put in a 2. So 2 minus 2y equals negative 8. I'm going to subtract 2 from both sides. Negative 8 minus 2 is negative 10. Negative 2y equals negative 10. Divide by negative 2 because we want to solve for a positive y. And y is going to equal 5. I'm going to take this, I'm going to plug it back into my equation. So, I'm going to do it down here, is 3 times 2 plus 4 times 5 equal to 26. Is 6 plus 20 equal to 26? It is. That's how we know our solution works. So our solution is going to be 2 and 5. Now, here's what's going to happen. Let's see. We're going to turn our page. And you're going to do problems 1, 2, A, and B. 1, 2, A, and B. So I'll let you go, get started. I'd like you to try to do it independently. When you are done, you can check your answers with the people around you before we go over them. All right, let's go over this. We should have immediately noticed in problem number 1, this positive y, this positive y, and this negative y. Because if we added these two equations together, these would cancel. They're opposites of each other. So I'm going to add them together. X plus x is 2x. Positive y, negative y, they cancel. We don't have to write it. And 3 plus negative 9 is negative 6. So 2x equals negative 6. I'm going to divide by 2. Divide by 2. And I'm going to get x equals negative 3. And I'm going to take this negative 3, I'm going to plug it back in. Negative 3 plus y equals 3. Add 3 to both sides. Y equals 6. I'm going to prove it. So I'm going to take my second equation and I'm going to prove that my answers are correct. So is negative 3 minus 6 equal to negative 9? Negative 3 minus 6 does equal negative 9, so I know that my answer is correct. I'm going to look at number 2. Number 2, we have a positive 2x and we have a negative 2x. And we know that those two will immediately cancel each other. They're opposites. So I'm going to add these two equations together. Negative 4y plus 6y is 2y. 10 plus negative 4 is 6. 2y equals 6. I'm going to divide by 2. And I'm going to get y equals 3. I'm going to take this 3. I'm going to plug it back in. So 2x minus 4 times 3 equals 10. 2x minus 12 equals 10. I'm going to add 12 to both sides. 2x equals 22. X equals 11. And I'm going to check against my other equations to see if it works. So I'm going to take this right here, the second equation, I'm going to plug in these numbers again. I'm going to do that over here. So is negative 2 times 11 plus 6 times 3 equal to negative 4? Is negative 22 plus 18 equal to negative 4? Yes, it is. So that's how I know that y is 3 and x is 11. My solution is correct. We'll look at A and B. In A and B, I immediately notice right here, positive 2x, negative 2x, they cancel. And that leaves me with y plus y. So 2y equals 4 because I'm going to add my equations together. I'm going to divide by 2, divide by 2, and I'm going to get y equals 2. I'm going to take this 2, I'm going to plug it back in. So 2x plus 2 equals 3. Sorry, let me rewrite that. 2x plus 2 equals 3. I'm going to subtract 3 from both sides. What am I doing? Ignore everything I just said. 2x plus 2 equals 3. I'm going to subtract 2 from both sides. I'm going to write 2x equals 1, which means x equals 0.5 or 1/2. I'm going to take that 0.5, I'm going to plug it in. So 2 times 0.5, or negative 2 times 0.5 plus 2 equals 1. We're going to see if this works. Negative 2 times 0.5 is negative 1. Negative 1 plus 2 does in fact equal 1. So that's how I know that my solution is correct. And last but not least, I'm going to look at B. When I look at B, I see this. Positive y, negative y. These two things cancel. X plus x, 2x. Positive y, negative y, they go away. 30 plus 6, 36. So 2x equals 36. X equals 18. I'm going to take this, I'm going to plug it in. 18 plus y equals 30. Subtract 18 from both sides. Y equals 12. I'm going to take this 12, I'm going to make sure I'm right. Is 18 minus 12 equal to 6. Look, I've taken my second equation, my two variables, I plugged them in. 18 minus 12 does equal 6. So I know that my solution is correct. Okay, everybody, you are going to go back to practice A, and we're going to do these bottom 4 equations, 4, 5, 6, and 7. You can work with each other, keep the volume to a low roar. All right. We're going to look at this first one right here, 3x minus 2y equals 1, 3x plus 2y equals 14. I'm going to rewrite it over here where I have more space. So 3x, I'm going to make that thicker. 3x minus 2y equals 1, and 2x plus 2y equals 14. Now, we should notice right here, positive 2y or negative 2y, positive 2y. These two things will cancel. So we're going to add our variables. We're going to add these two equations. 3x plus 2x is 5x. Negative 2y, positive 2y, they cancel each other out. 1 plus 14 is 15. 5x equals 15. I'm going to divide by 5 on both sides. And I'm going to write x equals 3. I'm going to take this 3 and I'm going to plug it into my equation. I'm going to pick my second equation to plug it into. So, what is 2 times 3 plus 2y equals 14. So I've taken this 3 where the x was, and I've plugged it into the second equation. 2 times 3 is 6. So 6 plus 2y equals 14. Subtract 6. Subtract 6. 2y equals 8. That means y equals 4. And let's see. I'm going to take these two and I'm going to plug them back in. So I'm going to use a different color. Use blue. Is 3 times 3 minus 2 times 4 equal to 1. I'm checking my answers against this first equation. 3 times 3 is 9. 2 times 4 is 8. 9 minus 8 does equal 1. So I know that my solution is going to be 3 and 4. Let's do this again for problem number 2. So in problem number 2, we're going to write x plus y, or problem number 5, however you look at it. X plus y is 4, and then 3x plus y equals 16. Now, I don't have two variables that are opposites of each other, but I do notice that my y's have the same coefficient. They have a coefficient of 1. So what I'm going to do is I'm going to take my top equation and I'm going to multiply my whole top equation times -1. And what that's going to change my top equation into is -x minus y equals -4. Because this -1, because this is a proportional relationship, this -1 multiplies into the whole problem. That's going to leave me with a positive y and a negative y, and they will cancel. So 3x minus x, 2x, 16 minus 4 is 12, 2x equals 12, that means x equals 6. I'm going to take that 6, I'm going to plug it in. 6 plus y equals 4, subtract 6 on both sides. Y equals -2. And I'm going to check it against my second equation, so use a different color, is 3 times 6 plus -2 equal to 16. 3 times 6 is 18. 18 minus 2 does equal 16, so I know that my solution is correct. We're going to look at number. We have 3x plus 2y equals -26. We have 2x minus 6y equals -10. If you notice, I do not have two perfectly offsetting variables, but I do have a positive y and a negative y. So what I'm going to do is I'm going to take this entire top equation, I'm going to multiply it by 3. Because when I do that, this will happen. I'm going to end up with 9x plus 6y equals -78. And now what I have is a negative y and a positive y. These two will cancel. I'll end up with 11x equals -88, which means x equals -8. I'm going to take this -8, I'm going to plug it back in. So 3 times -8 plus 2y equals -26. -24 plus 2y equals -26. I'm going to add 24 to both sides. 2y equals -2, which means y equals -1. And I'm going to check this equation. I'm going to plug it in. So I'm going to say is 2 times, I'm going to do this in a different color, is 2 times -8 minus 6 times -1 equal to -10. 2 times -8 is -16. -6 times -1 is +6. Is -16 plus 6 equal to -10? Yes, it is. So we know that our answer is correct. And then we're going to look at our word problem. All right. Our word problem says the sum of two numbers is -1. When twice the first number and 4 times the second number are added, the sum is negative 10. What are the two numbers? All right, we need two different equations. We have this key word here, sum, and added. Sum literally means to add, so that tells us what we're going to do with our problem. In our first equation, we know that the two numbers, when added together, equal negative 1. X plus y equals negative 1. Our second equation tells us twice the first. So we're going to say x is the first number. So 2x, 4 times the second, plus 4y equals negative 10. Now, if you notice, I do not have two offsetting variables, but I have an x and I've got my 2x. So what I'm going to do is I'm going to take my top equation, and I'm going to multiply my whole top equation right here times negative 2. Okay, this whole top equation times negative 2. And now, let's see. I'm going to end up with negative 2x minus 2y equals negative 2 times negative 1, it's positive 2. Now you should see right here, my two variables, negative 2x, positive 2x, these two will cancel. And we'll be left with 2y equals negative 8. If 2y equals negative 8, I'm going to divide by 2, y equals negative 4. I'm going to take this negative 4, I'm going to plug it in. So x plus negative 4 equals negative 1. I'm going to add 4 to both sides. X equals 3. I'm going to check this against my second equation. Is 2 times 3 plus 4 times negative 4 equal to negative 10? 2 times 3 is 6. 4 times negative 4 is negative 16. And 6 minus 16 does in fact equal negative 10. All right, I need everybody to open up their check for understanding number 2. There are, I believe, 3 questions. I'm going to work on it and then we will go over it. So let's get cracking. 3x minus y equals 5, 2x plus y equals negative 8. This is the first problem that we were going to look at, and it's going to wanting to know what is the y coordinate of this solution to the system. So what I immediately notice is I have a positive y and a negative y, and they're going to cancel. And so what I'm going to end up with is 3x minus 2x, that's going to be x. Negative y, positive y goes away. 5 minus 8 is negative 3. So x equals negative 3. I want to know the value for y, so I'm going to take this x, I'm going to plug it back in. So 3 times negative 3 minus y equals 5. Negative 9 minus y equals 5. I'm going to add 9 to both sides. Negative y equals positive 14, which means positive y equals negative 14. Let's see if this works. I'm going to take my second equation and I'm going to check my answer. So I'm going to say is negative 2 times x value, negative 3, plus negative 14 equal to negative 8. So in math, we try not to write plus minus, so we're really just going to write minus. So is positive 6 minus 14 equal to negative 8? Yes, it is. So that means my answer is correct, and my y value does equal negative 14. We're going to go past this one for a second. We'll come back to it. Two x plus y equals 12 and x plus 3y equals negative 1. I notice right away that I do not have a offsetting value, but I have a negative y and I have a positive 3y. So what I'm going to do is I'm going to multiply my top equation right here times 3. And that's going to leave me with 6x minus 3y equals 36. I'm going to combine my like terms, and I'm going to have 7x, no y's because positive, negative cancel. Negative 1 plus 36 is 35. 7x equals 35. Divide by 7. Divide by 7. X equals 5. I'm going to take this 5 and I'm going to plug it back in. So first equation, 2 times 5 minus y equals 12. 10 minus y equals 12. Subtract 10 from both sides. 12 minus 10 is 2, so negative y equals 2, which means positive y equals negative 2. And I'm going to check these two answers with my second equation. So, is 5 plus 3 times negative 2 equal to negative 1? Is 5 minus 6 equal to negative 1? Yes, it is. So I know that my answer is correct. Now let's look at this word problem. The seniors on the student council bought a total of 36 plants to use in the landscaping in front of the school. They bought some azaleas that cost $6 each and some lilies that cost $5 each. They spent a total of $196 on these plants. How many azaleas did the student buy? Okay, so we need two equations. Some things that I know for certain. I know they bought 36 plants. I know that it's $6 for lilies, or sorry, $6 for azaleas. I know its lilies are $5, and I know that they spent $196 in total. So my first equation, what I'm going to write, is I'm going to say that A plus L equals 36. Azaleas plus lilies is $36. Now, what I'm going to do for my second equation is I'm going to say that 6A, $6 for the azaleas, plus 5L, or $5 for the lilies, has to equal a total of $196. I don't have any offsetting variables, but what I want to do is I want to solve for A. So I'm going to take my entire top equation and I'm going to multiply it times negative 5. Because when I do that, I'm going to end up with negative 5A minus 5L equals, let's see, 30 times 5, 150, 180, equals negative 180. Okay? These two variables will cancel, and I'll be left with A equals 16. I'm going to take that 16, I'm going to plug it in. 16 plus L equals 36. Subtract 16 from both sides. L equals 20. Let's check it against our second one. What is 6 times 16 plus 5 times 20? Does that equal 196? 6 times 16 is 96. 5 plus 20 is 100. And that does equal 196. So they bought 16 azaleas, however you pronounce it. All right, people, that is all I have for you for today. You do have homework tonight. You have homework tonight. Your homework tonight is going to be to do homework number 5. Here, I'm going to show you what it looks like. This is homework number 5 right here. Homework number 5. You're going to do all of it. All of it. All. ALL 1 through 7. We will go over it first thing tomorrow morning. Get to work, take whatever remaining time you have to work on it, and whatever missing IXLs you may have that you owe me so that you are not working over Christmas break.